Okay, so for a problem like this, it says write the polynomial that has the roots 2i and 1 minus the square root of 2. Because 2i is a root, that means that 2i and negative 2i are roots, and 1 minus the square root of 2 is a root, and 1 plus the square root of 2 is a root. So when I write this out, to write my factors, I write x minus the root. So I just take x minus and then whatever these are. So it's going to be x minus 2i, x minus a negative 2i, which is like x plus 2i. And then for these, they look tricky, but if I just follow the rule, it'll work out. So I do x minus 1 minus the square root of 2, and then I do x minus 1 plus the square root of 2. So all I did was x minus the root. These are my roots. So now I'm going to deal with my i's and my square roots together. I keep them together so that they'll cancel for me. So over here, I'm keeping these together. I do FOIL. X times x gives me x squared. X times 2i gives me a positive 2ix. Negative 2i times x gives me a negative 2ix. Negative 2i times positive 2i gives me a negative 4i squared. The reason this is negative 4i squared is because negative 2 times 2 gives me a negative 4. I times I is just I squared. So now that I've done that, I'm going to deal with that in a minute and move on to this part. This part's a little more difficult. So for this one, I'm going to distribute this negative to everything that occurs behind it. When I do that, it leaves me with x minus 1 plus the square root of 2, close it up, times x minus 1 minus the square root of 2. So now, instead of a binomial like this, I have a trinomial, which is going to change things up. I can't use FOIL on something like this. So when I multiply this out, I need to do everything on the left hits everything on the right. So I take x all the way through what's happening over here. So x times x gives me x squared. X times negative 1